Hey guys, let's see today about solid design principles. So let me share the entire screen and we'll learn along and try to understand what is solid. So here you can see there are different URLs which are having for solid. You can see, right? Solid design principles, mastering solid principles, and this a lot of things are there. And design principles, different design principles. What are these? Cool. So first we will try to understand what solid stands for, and then only we are going to see. So here we can see solid stands for SOLID. S for single responsibility principle. What is it? Single responsibility principle. O is for open close principle. L is for least cost substitution, and then interface segregation principle is I, and D is for dependency inversion principle. Cool. So let's understand over each one by one. The solid design principles are 5 essential guidelines in object-oriented programming that helps developer create software that is Robert C. Martin, Uncle Bob, widely known as Uncle Bob in 2000. This principle address common software design flaws like rigidity and fragility by promoting loose coupling and high cohesion. So what is loose coupling and what is high cohesion, you should also understand. So loose coupling is like interconnection of two objects. Like suppose I have a class A. Let me show it here. Suppose I want to create a new file. Not like this. So okay, let me scroll it above. Yeah. So what is loose coupling? Let me write it here. Select the color. So here you can see loose coupling, right? Loose coupling is like suppose I have a class A, right? And inside this class, I remove this something like this. Okay, it's okay. Actually, it will work. So suppose I have a class A and then I have a reference of another class, maybe B class. I have another reference of B class. Okay, and somewhere we have B class also. And what is going to happen? Suppose I have B class here and A is having reference of this B1, right? So what is going to happen whenever we are going to create some constructor for A, inside it is kind of having the reference for this, so it is kind of tightly coupled, right? So this is what we call as tight coupling, and loose coupling is the process of removing the tight coupling is loose coupling. Loose coupling is like class A and B are not hardly related. They can be injected later. They can be injected. You must have heard of AutoAdd, right, in Spring Boot. So what happens? Spring Bean, what it does? Spring Bean basically injects the object of another class, suppose here B, into the class which is calling AutoWired, right? So if we have AutoWired, something like this, there is at the rate annotation, actually at the rate AutoWired, and then this bean is gets injected. So there is kind of loose coupling. Application context dot get bean, and it gets the bean injected at a on demand, actually at the class which is injecting at the rate of AutoWired, right? So this is loose coupling. Cool. And Now let's go to the 5 principles, which are solid principles. Is, as we know, single responsibility principle. Classes should have only one reason to change, focusing on a single functionality. What it is saying, single responsibility. One class should have one responsibility. Classes should have only one reason to change, focus on a single functionality, right? And we can dive deeper into this. Let me show that. Let's go deeper into each one with Java code example. With awesome Java code example. Okay. While it is loading, let's come back to here open close principle, which is the class software entities or the classes should be open for extension but closed for modification. What is saying? It is saying like if you have already a lot of you have a code base, large code base, and there some classes are there, and if you want some change, in that case what should be there? The class should be open for extension but closed for modification. Like it cannot be, you cannot directly insert some classes into that, some random methods which are not related to that. Cool. And it should be extendable, like it should be, we can extend it. Yeah. And then Lisco substitution principle, subclasses must be substitutable for the base classes without altering program correctness. So in place of subclass, there should be some parent class. Suppose I have in the same example A and B. Uh, suppose I have a new class C which extends from A. Cool. So in this case, suppose I create C is equal to new object. Basically what I'm doing, I'm creating a new object for C. In that case, what is happening here? C is creating a new object, but it is saying that if there is need, then we can replace this C instead of this subclass, which is C, with its parent class, which is A here. So this could be possible, and the logic should not break there. Like there should be some logic also, like if it is a bird, then A should also be kind of the child. Suppose it is flyable and something like that, then it should be replaced with that. We will see the example, perfectly working example in. And here after that, I is interface segregation principle, which clients should not depend on methods they do not use, prefer specific small interfaces. Basically it is saying that there should be interfaces should be very much differentiable, like there should be proper differentiation between interfaces. Like if you have some interfaces, the other interfaces, they should be kind of having different tasks, right? And also it is saying clients should not depend on methods. We will go into specific ones, more details. And then dependency inversion principle. What it is saying like depend on abstractions rather than concrete implementation. So what are abstractions? Basically abstract classes and interfaces. So it is suggesting the same thing, like depend on abstractions rather than concrete implementations. And what are the core benefits of this solid? Maintainability and flexibility, simplifies code maintenance and allows adding new features and minimal impact. And testability and reusability, facilitates easier testing and promotes reusable modular code components. So these are kind of already defined software principles, design principles. So we should, while developing or working with large projects in production or in companies, what we should do, we should remember like what are solid principles. If we are writing some interfaces or classes, then we should keep in mind, like, if this class is, what is the work of this class, what is the use of this interface, why am I choosing interface or class or any method which I'm writing, is it inside the classes? If there are multiple methods and doing different works, then those methods should be separated in a different class, right? There should be a single responsibility, like if there is a class which is sending notification, which is sending email, which is sending, printing some values, right? So a class is having three methods and each task is different. So what we can do, we can separate, we can give all the classes a single responsibility. By SRP means single responsibility. So why we are doing this, we can change our classes. We can say we can move email related method to email service, and then notification related method to notifications class, something like that we can segregate. So the task is very much segregated, and the class is having now a single responsibility. Like if it is a notification class, it is going to notification service, or notification class, it is going to send the notification only, not email or something like that. Cool. Now let's understand single responsibility. Concept is a class. So let's now we are diving deeper one by one, right? So let me go. Not here. Actually, Gemini is not giving proper response. Let me go to Chat GPT. Java example. So now we will dive into single topic. Actually, it is very important topic. Solid design principles. Every developer is being asked if you are aware of solid design principles or not. And then there is another term, design patterns, right? So design patterns are also asked things. One is solid design, one is design patterns, and other is design principles, right? So we are doing, let me see if we are doing. Cool. Cool. Now let's go to solid principles. Quick review. You can see first one is single responsibility principle, which is SRP. A class should have only one reason to change. SRP said there should be one reason to change for the class. That is single responsibility. Here you can see we have a user class and it is doing save to DB and then send email, just like I told earlier. So this class, the problem is DB plus email. It is doing two things. It is saving to DB also and sending the email also. This kind of class should not be there, right? A user class should have only the values related to user, like name, ID, and email, something like that, but not performing these tasks in the same class. And the good design would look like string. You can see here we have a user class which is having string name, and then for saving to DB we are having a user repository which is having save method and sending the meta user and then users, and then we have email service, send email user. For sending the email we have different class. So if you observe closely what is happening here, each class, here you can see each class is having a single responsibility or a single reason to change. That's why it is a SRP. We can say it follows SRP, single responsibility principle. So in while doing coding we could remember this, we should remember it actually. And what it says separation of concerns, and then easier in testing and maintenance, the benefits of this SRP. And when we move to what it says, open for extension and closed for modification. Open is for open for extension and close. This one is for close for modification. So a class should be extensible. Here look for the example. We have payment service what pay string type, and then it is checking if type dot equals UPI, do something UPI related payment. Else if type dot equals card, then we need to, you can see what we can do. We can do some card related payment. So in this class payment service, you can see it is checking if open for extension and close for modification. Is it possible here? So it is suggesting what we should do, since we have two types of there. One is API payment and one other is card payment. If there, suppose there comes some QR payment related to that, like QR payment, then what we have to do? We have to again add an else if type dot equals QR code, QR payment, right? In that case, we need to modify this payment service again, and what we just check, like the class should be closed for modification and open for extension. So it is kind of modification, it is not closed for modification. We need to add some modification for different type of card. So what we can do to better design it, we can do a payment interface. We can introduce a payment interface which will have a method pay which will accept different types like UPI, card, and then QR. Here you can see as it is happening, and then we have here UPI payment implements payment, right? You can see this, the different types, like we have UPI, then we have a class which is UPI payment, and then interface is just implementing that interface. Similarly, we have card payment which implements payment, and then the method is pay, and then this one. And suppose in future, okay, I'll just see the final class which is payment service. So payment service is saying what process payment, and then payment dot pay. 1 second. हाँ हाँ बताइए. अरे क्या हुआ बताइए, कहाँ पे बात है? अरे स्विच ऑफ हो गया था, आप बताइए, अभी बताइए ना, हो गया था. अब मुझे नहीं पता, बताइए फिर. अरे बताइए, कोई काम है? मैं काम कर रहा हूँ ना, अभी काम कर रहा हूँ, बताइए. Sorry guys, sorry. Let's go ahead. We have processed and payment dot pay, and add new payment, no change in existing. So similarly, if you have a different type like QR payment, then we are not going to do an else if kind of thing. What we are going to do, we are going to create a new class, just like card payment. We are going to have QR payment, implements payment, and then there will be pay, the same method, and then QR payment here. So this is open for extension. You can see add new payment, no change in existing code. So existing code is not changing. Cool. Now let's go to list cost substitution principle. It is widely asked. Out of this solid 5, suppose someone concentrates, some interviewer wants to ask, then what will happen? He will ask about this list cost substitution principle. They ask mostly about list cost substitution principle and DIP, which is dependency inversion principle. So let's understand Liskov substitution principle. It was developed by Liskov, actually Barbara Liskov, I think the name was, and it was developed by child class should replace parent without breaking the behavior. So here you can see, just like I told here, just here in the example, if you can observe this one, we have a child class. A is extending, sorry, C is extending A. So C is child, and when we are doing this, C is equal to new C. So if we can replace A, that is parent, instead of child without breaking the entire logic, then we can say that it is following Liskov substitution principle. So let's see a bad design first for Liskov. Child class should replace parent without breaking behavior, right? So if we have a bird, here you can see this class is having a method which is fly. Now we have a class ostrich which extends from bird and void fly. It is having the same kind of overriding the fly method, and it is saying or throwing new unsupported operation. Why? Because ostrich do not fly. So it is not in their behavior. So ostrich should be running, should be walking, something like that, but fly is not ostrich behavior. It is a bird, obviously it is a bird, but it is not flyable. So this design, logically this is, the code is fine, but logically this is not correct. What I want to say, this code looks good, it is compilable, everything will work better here because there's no mistake in code, right? But if you go to the logic wise, like if you remember real objects, since we are dealing with Java, ostrich is a real object and it is also a bird. And if you see ostrich behavior, their behavior is not fly, right? They do not fly. So logically or semantically, this method or this class which is overriding this fly method, this is illogical. So what should be the good design? We should separate something. What? There should be, like, we can make this bird class to be an interface first. Here look, it was class. Now we can make bird as an interface, and then the we can have different flyable or flying bird and non-flying bird, something like that. So here you can see interface flying bird extends bird word fly, right? Interface flying bird extends bird word fly. So this is one interface which is just using this fly method, which is just declaring this fly method. And now we have sparrow class which is implementing flying bird. So it will override this fly method, and then we have an ostrich which implements bird. You can see it is directly implementing from bird, not from the flying bird. Cool. So all the birds which are extending from flying bird, they would be fly, and other classes which are not flyable or not flying, they are directly implementing from the bird. So it is kind of complement. So which are not flying, which are other than flying bird, are the birds remaining which are non-flying, right? So here you can see ostrich implements bird which is no fly. So this is a good design, no broken expectations. And what we have done here, you can see child class should replace parent without breaking behavior. So what is the child class here? You can see instead of this bird, actually implements this hostage. So whenever we are going to use some for flying birds, suppose the sparrow is a flying bird, right? So instead of sparrow, we can use flying bird in this line. Suppose in this class actually, we can use flying bird instead of a sparrow because it is flyable also. So there won't be any logic error and no computation error. So this is Liskov substitution principle. And there are some other examples. Generally, people go with that example, and that is like duck. And the duck is kind of a plastic duck, and then that is toy duck, and then real duck. So real duck quack quack, but plastic duck do not quack, right? So that kind of we can have like quackable or yeah, quackable and non-quackable kind of interfaces we can create instead of flying bird. Yeah. Now let's go to interface segregation principle. What is ISP? Don't force classes to implement unused methods. So here you can see it is saying interface segregation. Segregation means separation. Don't force classes to implement unused methods. It is saying suppose we have interface worker and we have two methods, work and eat, right? And then for a normal worker, it can eat and it can work. But suppose I have a worker which is robot. In case of robot, as we know, robot can work but do not eat, right? They can be chargeable, there could be chargeable, something like that, but robot do not eat. So this method is not needed. Here you can see inside the robot method we have public void work and a public void eat and not needed. So what would be a good design? A good design would be we can have an interface which is workable, right? And then there should be an eatable. Cool. So basically, according to two methods or methods, we are creating a separate class like single responsibility. One should have, a class should have or should do one work or is responsible for one type of a work or one type of a task, just the single responsibility principle. So here you can see we modified it to workable. We created a workable interface and then eatable interface. So eatable is having method eat and then work. So these two methods from the worker are now pushed into interfaces. And now if we have a human which implements workable and eatable, then he can eat or work, which is good because humans do eat and work. But robot do not eat, they get charged, right? So public word work, and it is implementing only workable, not both workable and eatable. So it is a good design, clean interfaces. You can see it is segregated into these two methods are now segregated or separated into two different interfaces, and those interfaces give a proper meaning for each classes or subclasses which are implementing them, right? So it is good. So this is our ISP like interface segregation principle. Don't force classes to implement unused method or unrelated methods, you can say. And then dependency inversion principle. What is DIP? So it is suggesting depend on abstractions, not concrete classes. So here, if you can see my class, we have my class database and there is a method connect. So what it is going to do, it is going to connect with MySQL database, and we have a user service which is simply creating a DB connection by calling DB object. Here you can see it is just creating DB object, right? So here you can see it should be depend on abstraction, not concrete classes. So we are having a class which is a concrete class like MySQL Connect, and we are depending on MySQL. Here you can see this reference. Directly we are depending, and we are not depending on the concrete class. So for concrete class there should be a different way, right? We should avoid the using concrete classes inside this. So what we can do, a good design would say, first we can have a database interface, and inside that we are going to have this connect method and database. You can see here MySQL database, Oracle database, other databases, then can implement the database, and then this connect method can be overridden, connected to MySQL, connected to Postgres, connected to Mongo, something like that, different database classes which are implementing database, right? And now how user service would look, instead of this line which is creating instance for MySQL DB, we are having a private database instance, and then inside the user service we are just passing this instance or DB instance, and you can see this .db is equal to DB. And if suppose it is instead of MySQL, suppose it is MongoDB database implements database, then what would happen in that case? Since MongoDB database class is also a database, right? It is subclass of database. Then here also MongoDB would work and it will not break the code. So easy to switch DBs like Mongo, Postgres, Oracle, other MongoDB. So this is the dependency inversion principle. It says depend on abstractions, not concrete classes, right? So let's see the interview killer summary. You can see explain solid with example like SRP one class, one responsibility. OCP extend without modification. LSP child should not break parent behavior. Cool. And then ISP small focused interfaces, and DIP depend on abstraction, not the concrete classes. Cool. So here you can see senior level insight. Solid is not theory, it directly impacts microservices design, Spring Boot architecture, testability, and then scalability. So that's all, guys. This was wonderful. Thank you for being here. Now closing the stream for now. Thank you, guys.